Okay, hi students. So today we will be looking at this question from 2018 AJC promo question 7. So the diagram below shows a cube with length L. The main diagonals are formed from line segments and all that information. Use a vector method to show that the acute angle between two main diagonals AG and BH is independent of L. So this is a hint to us that we need to find out what AG and BH can be defined as. So AG, alright, is given by this vector like this. Okay, this is vector AG. So let's think about how do we define this. So by vector addition, you will have to travel A to B, B to C, C to G like this. Okay, so this is L units of the vector I. Okay, so what I'll do is I'll write L vector I followed by L of vector J here, right? Because vector J, is over here. So it'll be L of vector J. And then now I'm going to go upwards. So it will be plus L of vector K. But usually, it is always easier to read this in column vector notation compared to IJK notation. So what I'll do is I'll convert this into column vector, which will be L, L, and L. Okay, so that is for AG. Let's do it for BH this time. So for BH, it will be B to H like this. This is my vector in question. So how do I define it? I will be going to the left now, which is the opposite direction of the vector. Okay, so it will be negative I, followed by going up here will be a K, and over here it will be J. Okay, so for the vector BH, first of all, I'm going in the opposite direction, so it will be negative L units of vector I, followed by vector K, right? It will be L units of vector K. So L units of vector K followed by L units of vector J. Again, writing this in column vector, it will be negative L, L. Okay, so again, we have to relate this to the acute angle between the two vectors. So we will have to use this formula that you will have been introduced to when you learn the initial stages of vectors. Okay, so it will be AG dot BH equals to modulus of AG modulus of BH cosine theta. Okay, so on the left hand side, I will be doing a dot product. So it will be L, L, and L dot with my negative L, L, and L. Okay, then when we take the modulus of the vectors, we are essentially finding the magnitude. So it will be Pythagoras theorem. So it will be L square plus L square plus L square, followed by negative L square plus L square plus L square, and then cosine theta. Okay, so from here, I will then evaluate this dot product. Okay, so dot product says that we will multiply horizontally and we'll sum them up. So it will be negative L square plus L square plus L square. Over here, let's evaluate what is within the square roots. It will be 3L square and 3L square respectively. Okay, simplifying this is L square followed by square roots when they multiply together, and they have the same term within it, so we'll just remove. So it will be cosine theta. Actually, before we evaluate all this, it will be good if we define the acute angle to be theta. So what we can do is we can add in this line here. Okay, so I'll shift everything down. We can add in let the acute angle be theta. Okay, this is an optional step, but it will really make your explanations very clear. Okay, so over here, I'll divide away my L square. So we're just left with 1 equals to 3 cosine theta. So theta equals to cosine inverse of 1/3. Okay, so we will then write shown because the acute angle is indeed independent of L. So I'll say shown because theta is independent of L. Okay, so this is for part A. Let's look at part B, which is a completely different question. In triangle ABC, the vectors A, B, and C are represented like this. Write down C in terms of A and B. So let's look at C in this case. In order to find C, it is essentially finding vector BA. So how do we find vector BA? That means I'll travel to C from B and then I'll travel from C to A. So vector C is just A. Okay, this is vector A, and I'll go here, which is vector B. So it is vector A plus B. Okay, so that is for the first part. Next part, by considering modulus of A cross C. So what I'll do is that I will literally take that advice, okay? Let's consider A cross C. So it will be modulus of A cross C. Okay, previously we know that C is A plus B. So what I'll do is I'll replace it with A plus B like this. Okay, from here what I'll do is I will actually evaluate what is in my modulus here. So it is A cross A, just expand it, okay, like how you do your rainbow. But it will be A cross A plus A cross B. Now, in vector product, we learned that A cross A, the resultant vector is a zero vector. Because A cross A will give us modulus A, followed by sine, but because it is the same vector, the angle produced is 0 degrees, which will make the whole thing 0, so this whole thing will become 0 as well. So what we're really left with is actually just a modulus of A cross B. Okay, 0 plus A cross B. Okay, so in the end, I will just have modulus A cross C equals to modulus of A cross B. From here, based on the vector product definition, let us evaluate this. So you will actually get modulus A, modulus C, sine of a certain angle, agree? So let's go by the diagram to see what the angle is. If we're looking at A and C, do you all see that vectors A and C, they actually diverge? They diverge away from which angle? From angle B. Okay, they diverge away from this angle. So it will be sine B. Take note that the vectors must either converge to the angle or diverge away from the angle. Because for the next portion, here you'll get modulus A, modulus B, sine of an angle, right? But as you can see here, vectors A and B, they are not really converging to an angle or diverging away from the same angle. So in order to evaluate this, I must extend my line here. And do you see that this is vector A as well? Because it is traveling along vector A. So if I just extend it, this is also part of vector A. Now, do you all see that this vector A and this vector B, it is diverging away from this angle, which I'm going to call alpha. Do you all see that? It is diverging, right? Diverge, diverge. So right now, I can comfortably write sine alpha. But take note that the question wants us to relate B and C for our shown answer. So definitely, eventually, I must replace it with C somehow. So first of all, our modulus A can be cancelled on both sides because it is a constant. So I'm just left with modulus C sine B and modulus B, okay, sine of alpha. How do I relate back C? Okay, what I can do is, since this is angle C, in order to find angle C, it is 180 degrees minus away C, right? the alpha can be replaced with sine of 180 degrees minus away C. Okay, can you all see that? Here is my angle C, so to find alpha, I take 180 minus away C, adjacent angles on a straight line. So you have learned this in E-Math last time in secondary school. Sine of 180 degrees minus theta, this is my supplementary angle formula to give us sine theta. So this will just give me modulus C sine B equals to modulus B sine of C. So now let's put it into how the question wants it. They divided away the modulus, right? So it will be sine B over mod B, just divide away, equals sine C over mod C. Okay, then I'll write shown.